Hello. In this video, we're going to be solving question 2. Question 2 asks, you went around campus and asked what most students are worried about, and you got 300 people in X1, 200 people in X2, and 100 people in X3, X4, and X5. Now, given that X is the transpose of the X1, X2, X3, X4, X5 matrix, write out the equation for P of X. Now, there are two ways to do this. Both are very, very easy. There could be more ways, but these are the two ways that I know of. The first is you can think of the problem as P of X equals theta 1, X1, theta 2, X2, theta 3, X3, theta 4, X4, theta 5, X5. If you want to generalize this, it would just be the sum for all I equals 1 to n of theta sub n to the x sub n, right? And in this case, we just need to remember that x sub n is equivalent to 1 or 0, 0 or 1, depending on whether or not, we're choosing that option, if that makes sense. Right? So in this case, what this formula would tell us to be, is that it would be P of X, and then theta 1 would be the total number of people in X1 divided by the total number of people overall. So there are 300, 200, 100, 100, 100, which sums up to 800 people. And so that would be 300 over 800. So a little trick, we can just do 1 over 800 times 300 to the x sub 1 times 200 to the x sub 2 times 100 to the x sub 3 times 100 to the x sub 4 times 100 to the x sub 5. And what this essentially does is, let's just envision that you wanted to use this equation to actually solve for some sort of x, right? So let's choose x sub 2, right? And so in this case, by the way, I forgot to include this, x always is equivalent to x sub 1, x sub 2, x 3, x sub 4, x sub 5, right? And so if you're going to plug in an x, well, if you're trying to find specifically a value for, let's say you wanted an x2 to be the people that you wanted, or maybe you wanted to get all groups of x3 and x4, right? Let's say you wanted all groups of x2. That's probably the easiest to start off with. Then this would become 0, 1, 0, 0, 0. And if you plug this into the equation, you get P of x is equivalent to 1 over 800 times 1 times 200 times 1 times 1 times 1. Right? And that is just 200 over 800, which is the probability of x2, because there's 200 people out of 800. So this is a valid formula, as long as you specify that x is equivalent to x1, x2, x3, x4, x5. And you specify that it has to be equivalent to that. This is part of the definition, what I'm highlighting in red. Another way to think about this problem is you could lay it out sort of piecewise. You could say x1, so a completely separate way of thinking about this problem that will arrive at the same answer, but it's a very different way of thinking about it. You can say x1 is 300 people, x2 is 200 people, x3 is 100, 4, 100, 5, 100. And then instead of making px into a nice continuous formula that is applicable for all of them, because we only have 5 cases here, we can make a piecewise instead, because they are functionally identical. So you would do 300 over 800 and then you do 200 over 800 and 100 over 800, and then you'd have 0. And then all of these would have their cases, so this would be x1, x2, x3, 4, 5, and then elsewhere. And you'd have to include all the cases here, but in either case, this would also work. I believe the first solution is generally what we suggest to use in class because it's more in line with our course concepts, while the second method is a little bit of a bootleg manner that takes advantage of several of the specifics of this problem to work. All right, but in any case, that's problem 2. Good luck.